Global warming. The Earth receives energy from the Sun, more at the equator and less at the poles, but on average the energy from the Sun is at an intensity of around about 1000 watts per square metre. Now to the Sun the Earth appears as a disk with area pi r squared, where r is the radius of the Earth. So the power entering the Earth will be the intensity of the sunlight, 1000 watts per square metre, multiplied by the area of this disk, giving a power of 1000 pi r squared watts. But the Earth will radiate energy out from the whole of its surface, like this. There will also be energy coming towards us and away from us. If this is at a power p per square metre, the power being radiated out from the Earth will be given by PA, where the area of a sphere is 4 pi r squared. So the power leaving the Earth will be 4 pi r squared P. At equilibrium, the power entering the Earth must equal the power leaving the Earth. So we can say that 1000 pi r squared, which is the power entering the Earth, is equal to 4 pi r squared P, the power leaving the Earth, meaning a power leaving the Earth of 250 watts for every square metre. Assuming the Earth to be a black body, it would need to be at a temperature of around minus 13 degrees C to have a power output of 250 watts per square metre. This is clearly too low an average temperature to support life as we know it. The greenhouse effect has reduced the energy leaving the Earth, so causing the temperature to rise. Global warming. As the temperature rises, the amount of energy leaving the Earth will increase. The hotter a body, the more energy it radiates. Eventually, an equilibrium temperature is reached again, at which the energy entering the Earth equals the energy leaving the Earth. The energy we gain from the Sun hasn't changed, but the energy leaving the Earth has increased until they reach this equilibrium position. This is at a current mean temperature of the Earth of around 15 degrees C. Let's just look at the situation on the two planets which are nearer to us than the Sun. Mercury, the nearest planet to the Sun, has no atmosphere. It clearly gets a very high power input from the Sun and has huge temperature differences, but an average temperature of around 167 degrees C. Venus, further out than Mercury, has an atmosphere of carbon dioxide and sulfur, and being further away from the Sun, it will receive a lower intensity of radiation from the Sun, but a huge greenhouse effect on Venus has led to it having an average temperature of a massive 464 degrees C. That's hot enough to melt lead. So what causes the greenhouse effect on Earth? Well, mainly water vapour, carbon dioxide and methane in the atmosphere. The burning of fossil fuels has increased the levels of carbon dioxide in the atmosphere, and as global temperatures rise, carbon dioxide which is currently dissolved in the oceans will be released. The warmer a liquid is, the less gas it can hold. This will also cause water vapour levels to rise, so further increasing the greenhouse effect. The mean temperature of the Earth has changed little over the last 1,000 years, but since the 1980s temperatures have started to rise. Now to look at some of the effects of global warming. Well, we will have more extreme weather, more droughts, more floods, for instance. Sea levels will rise as the ice caps melt, and changes of weather may affect ecosystems, leading to a loss of habitat.